and welcome to the video. In this video we are going to look through the process of enlarging shapes, the process of enlargement. We're going to look at it from a very mathematical point of view, from a typical exam question point of view. That is, enlarging shapes while they are placed on a set of axes. Maybe the axis involves the 4 quadrants, or maybe it just deals with one quadrant. Either way, the method would be very similar. Okay, so this is a very typical question. Enlarge this shape by a scale factor of 3 with a center of enlargement at -3, -4. First thing we need to do is we need to find the center of enlargement and mark it on the axes. In this question, you can see I've already done it for you. I've put a black dot at the coordinate -3, -4. This is our center of enlargement, vitally important for ensuring our enlarged shape finishes where it should finish. Okay, we're also going to enlarge this shape by a scale factor 3. What that means is our resulting image, our resulting shape, each length should be 3 times as big. So this shape here starts with a height of 2 squares. By the time I'm finished, that should be multiplied by 3, and I should have a height of 6 squares. The length of this rectangle is 1 square, so I would be expecting 3 squares on my completed image. Okay, so my first instruction would be, when you get a question like this, if you go to the center of enlargement and draw a straight line that touches the corner, and then you continue it to cover most of the axes. If you do that for all corners, so center of enlargement, touch the corner, continue it on. Center of enlargement, touch the corner, continue it on. And finally, center of enlargement, touch the corner, continue it on. Okay, so we are adding on 4 lines here because there's 4 corners of this shape. At this point in the video, I should point out that these lines are not necessary. You might see other tutorials which don't talk about adding the lines on. They say they're not required, they say they're not needed. For me, I always think it's a brilliant idea to include the lines because it works as a safety net and it ensures your answer is correct. And I'll show you how that works on the next slide. Okay, so we're going to enlarge this shape by a scale factor of 3 from a center of enlargement -3, -4. Okay, so I've got my shape. I've drawn on my 4 lines. Okay. If I look at this corner here, I'm going to count the squares from the center of enlargement until I get to this top left-hand corner. So you can see it's 1, 2, 3 squares up, 1 square along. Because I'm dealing with a scale factor of 3, I'm going to times those numbers by 3. So 3 times 3 is 9, and 1 times 3 is 3. So I then go back to my center of enlargement and I count the numbers 9 up, 3 along. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. And this is where those red lines become important. This is where they become your safety net, because the top left corner of my new image, it lands on the red line. So already I know that this point is accurate. If my pointer dropped here, 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 or here, I would know there was a mistake with my counting or possibly a mistake with the accuracy of my lines. So as soon as my new corner lands on one of those projected red lines, I can be pretty confident I'm doing my method correctly. Just going to change to a different color. So this time I'm going to look at this corner. I'm going to do the same thing. Start at my center of enlargement and count to get to the green dot. 1 up and 1, 2 along. Okay, I'm going to times those by 3 because my scale factor was 3. So I'm now going to go 1, 2, 3 up, 1, 2, 3, 4, 5, 6 along, and as we would have predicted, again, I land on a red line. So you can see this bottom right corner of my original image. This is where the bottom right corner of my new image is going to be. I'm going to change again for the color of my highlighter to make it a little bit easier to see. If I go for this far corner, top right, to get there from the center of enlargement, 1, 2, 3 up, 1, 2, 2 along. Go back to the center of enlargement, times those by 3. So that's now going to be 9 up, 6 along. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. And again, we're landing on a red line. That safety net is telling me throughout the question I'm doing this correctly. I'm going to change my highlighter for one last time. We can probably predict where my last corner is going to go. Okay, so once we get confident with this topic, once we've done 3 of the corners, we can probably predict the 4th one, but just for completion, I'm going to work through this corner as well. To get to the bottom left corner, I go 1 up, 1 along. I go back to my center of enlargement, times those by 3. 1, 2, 3, 1, 2, 3. Again, I'm landing on the red line. So you can see where my new shape is going to be formed. So if I now join those up and draw in my image, this will be done with a ruler when you have a go at it. There is my new image. Notice that all 4 corners land on one of the projected red lines. If I shade that in a little bit to make it stand out, there we go. That is what my completed image looks like. And if we have a look, this line here was 1 along. It had a length of 1. Now it has a length of 3. That would be expected because we're dealing with a scale factor of 3. This height here is 2 squares up, and this height here is now 6 squares up. That would be expected because we're dealing with a scale factor of 3. So when we talk about the scale factor, we're talking about the linear scale factor. How big have the lines become? How much have we extended the lines? How much have we multiplied the lengths by? It is nothing to do with area. So the area scale factor would be different. Now you can see I've completed my enlargement. Here's my original shape. I used my center of enlargement. I used some straight lines as a safety net. I did some accurate counting of squares, and I produced my larger image, which is this one here. Okay. Another question to have a go at. You may want to pause the video now and have a go at this one yourself by copying out the axes in the question and completing the question yourself. If you want to pause the video, pause it now. And then if you don't want to pause the video, I will talk you through this example. Okay, first thing I'm going to do is I'm going to look at my question. My center of enlargement is at -3, 4. So I go to the coordinate -3, 4, and I drop my center of enlargement. It was already on this question. Sometimes it won't already be on, and you'll need to find that center of enlargement. This time I'm only dealing with a scale factor 2, so I can expect my enlarged image to be twice as big as the original question. This is 2 along, so I would be expecting the base of my triangle to be 4 long in my enlarged shape. First thing I'm going to do is I'm going to draw some straight lines from the center of enlargement. There we go. This time there's only 3 lines. because obviously a triangle has 3 corners. From the center of enlargement, touch the shape, continue it on. Center of enlargement, touch the shape, continue it on. Okay, now we're going to go ahead and count some squares. To get to this corner here, I go 1 along, 2 down. This time I'm multiplying by 2 because my scale factor was 2. So I'm now going to go 2 along and 4 down. Again, I'm landing on a red line, using that safety net to make sure my answers are correct. To get to this corner, I'm going to go 1, 2, 3 along and 2 down. Go back to the center of enlargement, times those by 2. So I'm now going to go 6 along and 4 down. 1, 2, 3, 4, 5, 6. 1, 2, 3, and 4. So that is where that corner of the triangle is going to land. Again, at this point, we could predict or work out or estimate where the final corner is going to go, but just for completion, I'm going to complete it. So to get to this point here, from the center of enlargement, 1 along and 0 down. Go back to the center of enlargement, times those by 2. So I'm going to go 2 along, 0 down. Lands on the line, so I'm quite confident I've done that correct. Then I'm going to take my ruler and draw in my new shape by connecting these new corners. Once I give that a little bit of shading, it will look like this. And again, because I've doubled the distance from the center of enlargement, my linear scale factor will have doubled. The length from here to here was 2 squares. It is now 4 squares down. The length from here to here was 2 squares. It is now 4 squares along. If we took a ruler and measured this hypotenuse, this distance here, it would be exactly double on the enlarged image. Again, those red lines are there as a safety net. Once you get confident with the topic, you may not need to include them. Some tutorials won't show them, but for me, it just makes sure, just means that you're doing the topic perfectly and really building your confidence with the idea of enlargement. Okay, now it's your turn to have a go at a few questions. I put 4 questions on the screen. This time I've just used 1 quadrant rather than all 4 quadrants. However, the method and the process for doing the enlargement is exactly the same. For each question, make sure you read the question, have a look at the 2 vital bits of information, the scale factor, and of course, the center of enlargement. For the first 2 questions, I've already found the center of enlargement for you. For question 3 and 4, you will have to also do that part of the question. For each question, could you copy out the axes and complete the enlargement accurately? Okay, would you like to pause the video now? Okay, welcome back. I'm going to show you my solutions to each of these enlargements. They should look like this. So you can see for question 1, 2, and 3, we're dealing with a scale factor of 2. So each linear dimension on your enlarged shape should be double what it was on the original shape. You can see I've used my straight lines just to confirm I'm doing this correct. And I know that every corner on my enlarged shape will also be landing on one of those red lines, just filling me with confidence that I've completed the questions accurately. Very well done if your 4 enlargements look like this. Okay, I'm going to move on and do another example. So this time we've changed the question very slightly. The scale factor is now a fraction. The scale factor is fractional. So I'm dealing with a scale factor of 1/2. Everything else in the method is exactly the same. So if you've understood the beginning of the video, this part of the video, hopefully you'll be able to understand quite easily because we're just going to change one little aspect of the method. First thing is we're going to find the center of enlargement, -5, -2, which we've done here. Find the center of enlargement and put the dot. Then we're going to add on our lines from the center of enlargement to each corner of the shape. So it's going to look like that. Because we're dealing with a fractional enlargement, the shape is actually going to get smaller. So we don't need to worry too much about extending the lines past the shape because our answer, our image, our enlarged shape is going to end up in this region here somewhere. Even though we're dealing with a fractional scale factor and the shape is going to become smaller, mathematically, we still refer to it as an enlargement. So your answer is going to end up smaller because we've used a fraction as the scale factor, but we still refer to it as an enlargement. Okay, the process from here is the same as the process for counting the squares at the beginning of the video. I'm going to count the squares to this yellow corner. 1, 2, 3, 4, 5, 6 up. 1, 2, 3, 4 long. This time I'm going to times them by 0.5. I'm going to half those distances. So I'm now going to go 3 up and 2 along. 1, 2, 3, 1, 2. Again, I land on my safety net. I land on the line. Okay, if I now look for this corner, to get from the center of enlargement to the green corner, 1, 2, 3, 4. 1, 2, 3, 4. I'm going to half those distances, so it's going to become 2, 2. I go back to the center of enlargement, 1, 2, 1, 2, and I land on a red line. Then I'm going to look for my third corner. We'll go for this one here. To get there, I go 1, 2, 3, 4 up. 1, 2, 3, 4, 5, 6, 7, 8 along. So I go back to my center of enlargement and I'm going to go 2 up, 4 along. 1, 2, 1, 2, 3, and 4. Land on a red line. For the last one, we can probably see where it's going to end up. We're pretty confident it's going to end up here, but let's do the counting just to be totally sure. 1, 2, 3, 4, 5, 6 up. 1, 2, 3, 4, 5, 6, 7, 8 along. Back to the center of enlargement. 3 up, 4 along, and as expected, we land there. Then we go to draw in our shape. So we match up the new corners to get our enlarged shape. So even though it's ending up smaller, we're still referring to it as an enlarged shape. If I was to shade that in slightly, it would look like that. So here is my original shape. Here is my enlarged shape. If I look at the lines of the original shape, 2 up, because my scale factor was a half, that distance is halved, and it's now become 1. This length here was 4. Because my scale factor was a half, that halved, and the distance is now 2. So here is my enlarged shape using the scale factor 1/2. Okay, so here's another question for you to have a go at. If you want to work through this question yourself, copy out and complete the question and pause the video at this point. If you would like another example, please keep watching the video. Okay, this time we're dealing with a scale factor of 1/3, so the shape is going to end up 1/3 of its original size. Center of enlargement is at -4, -4, so I find my center of enlargement and put the black dot. There's my center of enlargement. I take my ruler and I add on lines from the center of enlargement to touch the corner of each shape. Now I'm going to go ahead and count some squares. Remember, our scale factor is 3 this time, so every distance is going to get divided by 3. So to make my way up to the top of the triangle from the center of enlargement, 1, 2, 3, 4, 5, 6, 7, 8, 9 up and 3 along. Divide those numbers by 3. now becomes 3 up, 1 along, and as expected, we land on the red line. To get to the right angle in this triangle, we would go 3 up, 3 along, divide those numbers by 3, back to the center of enlargement, 1 up, 1 along, there we go. And to get to this corner here, we're going to go 3 up and 1, 2, 3, 4, 5, 6, 7, 8, 9 along. Back to the center of enlargement, 1 up, 3 along, there we go. Then you're going to take your ruler, draw in your new triangle, matching up the new corners, and it will be 1/3 of the size of the original shape. With a little bit of shading, my shape looks like that. Because I'm using a scale factor of 1/3, this distance here, which was 6, is now a length of 2. And similarly with this distance here, it was originally 6, now it's a length of 2. This is my enlarged shape, even though it's smaller, we still call it an enlargement, and we've enlarged this triangle by a scale factor of 1/3. Okay, now it's your turn to have a go at a few questions. So again, you have the ability to pause the video at this point. For each question, could you copy and complete the axes? We're back to working in one quadrant. And then could you enlarge the shape by reading the question correctly, taking the 2 bits of information, scale factor and center of enlargement, and having a go at creating each enlargement. Again, for question 1 and 2, I've already found the center of enlargement for you. For 3 and 4, you'll have to do that yourself. Could you please pause the video now? Okay, welcome back. I'll show you my solutions to these enlargements. Every question had a fractional scale factor, so your answer should always be smaller than the original shape. You can see from each of mine that if I was to look at the scale factor, a half, look at one of the lengths, 4 squares along, and half the length, it is now 2 squares along. The red lines are there as our safety net. As you're gaining confidence with the topic, you may not be including those red lines, but my advice is always to keep them included just to make sure you're 100% correct with your answer. Okay, last task to have a go at. So just to consolidate this topic, I put 6 final enlargement questions on the screen. The top 3 use a scale factor of 2, and the bottom 3 use a fractional scale factor of 1/2. So if you need a little bit extra practice with this topic, this is your opportunity to do that now. For each question, could you copy and complete the axes and complete the enlargement by reading the question correctly? Could you pause the video now? Okay, welcome back, and we'll just quickly go through the final solutions of the video. They should look like this. So you can see on the top 3, because we're using a scale factor of 2, each image has got bigger, each image has been enlarged, each linear distance is now 2 times as big. And if we look at the bottom 3 questions, because we're dealing with a fractional scale factor, then each shape has ended up smaller, but we still refer to that as a mathematical enlargement. Okay, if you've been able to produce some very good enlargements throughout this video and followed the instructions correctly, then that's excellent. You've shown a great understanding of enlarging shapes.